Okay, y is inversely proportional to x. It says inversely proportional to, and when x is 2, y is 1. Find the equation connecting x and y and sketch its graph, and then find the value of y when x is equal to 16. Okay, so y is inversely proportional to x. So we now write this now. Y, this means proportional to, but if it's going to be inversely proportional, we now have to write it as 1 over x. And therefore, that now means that y is equal to k over x. So if we got y is equal, when x is equal to 2, y is equal to 1, then we can find the value of k by substituting 1 is equal to k over 2, and that gives me the value that k must be equal to 2. So my equation must be y is equal to 2 over x. Now to the sketch, because we have to sketch it, if we draw a set of axes, and then I'm going to go to my GeoGebra applet like I did in the previous video. There's a few things I need to change in the previous video. That is what the previous video applet looks like when you get it. Okay, so you have to unselect that one, select that one, and then in here you now have to change the function to k divided, you have to use the slash button for divided by x. Okay, now the graph here is the graph of 1 over x. What we can see here, when x is 1, y is 1. When x is a half, 1 divided by half gives me 2. When x is a quarter, 1 divided by a quarter gives me 4. Okay, and then so on. Okay, at 4, 1 divided by 4, this will give me a quarter. At 2, 1 divided by 2, this will give me minus a half, plus a half, okay? Over here, what happens here is, of course, it's negative, it goes the other way. Now, you've got these things where it never quite touches the graph, because these are called asymptotes. Okay, so I wanted y is equal to 2 over x. So if I now move this, and the same sort of idea what happens is at every point, so if you see this point here, what happens, it gets doubled. Same over here, this distance here gets doubled, this distance here gets doubled. Let's take this one here, this distance here becomes doubled to that point there. So what happens, it stretches the graph by 2 units parallel to the y-axis. Okay, so this applet I'll put in the notes in the video, but you do need to make those changes before you start using it. Okay, so what I'm going to do here, if that's 1 unit, 1 divided by 1 is 1. 1 divided by a half is going to be 2. And then 1 divided by a quarter is going to be 4. And then over here, 1 divided by 2 is going to be a half, and then 1 divided by 3 will be a little bit lower than that, because it's only a sketch, okay? So that's the first part of y is equal to 1 over x. And then similarly, the same idea over here, but everything's now negative. So the 2 units here represents minus 1. Okay, same idea. And then we got our graph here. So this is the graph of y is equal to 1 over x. To do 2 over x, then obviously what I do is I now look at that distance and double it. Same here. And then I can get a graph like that, like I did in the GeoGebra applet. Same in the negative part. I get a graph like that. Okay, again, it's only a sketch, so it doesn't have to be perfect. Now, what happens here, the same idea here, we get what's known as asymptotes. This is the spelling of asymptotes. So this one is called a horizontal asymptote, and this one here is called a vertical asymptote. See, the graph gets closer to it, but never actually touches. Similarly, at the other end, there are asymptotes as well. Okay, we're asked to find the value of y when x is equal to 16. So when x is equal to 16, we put 16 into this. We're going to get y is 2 over 16. Y is going to be equal to 1/8. So this has been a video to show you a graph of a function which is inversely proportional to x. I'll remind you the GeoGebra applet is in the notes of the video. You will have to change the initial things as indicated in the video. Thank you very much for watching.